Okay, so now let's cover the reciprocal trig functions, namely cosecant, secant, and cotangent, and particularly the graphs of these functions. So I'm going to start out by just briefly introducing all three of them, in general how to get the graph, and then I'll go through a couple of specific examples. So let's start out with cosecant, the graph of cosecant. Now, over here, I have the graph of sine of x, and you can see there's a period of 2 pi, amplitude of 1. So this is the standard graph of sine x. So what would the graph of cosecant x look like? Well, let's remember that cosecant is 1 over sine. So when you're first getting used to these graphs, and they can be a bit to get used to, they're kind of odd looking compared to what you've seen with the sine and cosine. So I'm going to use this blue graph of sine as a guide and use this to get to a graph of cosine. So let's start with some key points here. And remember, it's just going to be 1 over, cosine is just going to be 1 over these points. So I'm going to make those points in red. Now let's start over here. 1 over negative 1. Well, 1 over 1 is going to be 1. 1 over negative 1 is going to be negative 1. Right, so far so good. Now, look, we have some points here where sine of x is equal to 0. 1 over sine of x is equal, sine of 0 is equal to 0. Well, sine of x is equal to 0. Cosecant x is 1 over sine x, or 1 over 0. Well, it's undefined here. Cosecant is going to be undefined because what you would have is 1 over 0. So what I'm going to do is, well, as I could do this here, is I'm going to draw. I don't want to draw it this thick. I'm going to draw an asymptote here. This is going to be a vertical asymptote. Same thing here. 1 over 0 does not exist, so I'm going to draw a vertical asymptote here. 2 pi again. So let's see what this graph is going to wind up looking. Let's look at between 0 and pi over 2. Well, 1 over 0. So you kind of should remember, if you remember a little bit from graphing rational functions, what has to happen here? Well, this graph has to approach a vertical asymptote. It works the same way. Vertical asymptotes basically behave the same way here. And notice all of these numbers are positive. So all of the reciprocal numbers, I can't divide 1 over a positive number to get a negative. So this graph has got to go up to infinity. Same thing on this side. You have a vertical asymptote that it has to approach, but of course these are all positive numbers, therefore the reciprocals will be all positive. Now do the same thing down here. Again, reciprocals and vertical asymptotes, but which way is it going to approach the vertical asymptote? Well, everything in here between pi and 2 pi is negative, so all the reciprocals should therefore be negative. And your graph of cosecant is going to look something like this. And I could continue this to make another point here. This is, try to keep this in scale. Make another point, negative pi, and yeah, this is going to be not quite to scale as much, but I'll have another. But you see we have asymptotes every pi units. So I'll have another one down here, more or less. So this is the pattern, you see. You kind of see these paraboloid, not really parabolas, but parabola type graphs, down, up, down. So that's what, that's cosecant. Now let's look at secant. Secant is going to be very similar. We're going to do that the exact same way. Secant is 1 over cosine. So where are the zeros here? Well, cosine is equal to, cosine of x is 0, over here. So wherever cosine of x is 0, secant of x will be undefined. It'll have a vertical asymptote. Wherever cosine of x is 1, secant of x will be 1. Wherever cosine of x is -1, secant of x will be -1. So you see the pattern here. I'm doing that, and then I'm kind of drawing these kind of opposite, right? This goes up this way, the cosecant graph, a cosine graph, and the secant graph goes down this way, but you can see it's the same pattern. And I can even draw minus pi over 2, or rather minus pi over 2, and have this go this way. And you get the idea. Finally, cotangent. Now again, here's a tangent graph. Now, okay, tangent graph already has these asymptotes here, but we're basically going to do the same thing. Let's take a look at where, again, cotangent. So let's do the same thing here. Now, where the tangent is 1, a cotangent is 1 over tangent. So I'm going to make the cotangent graph in red. Well, again, if tangent is 0, tangent of x is 0, then cotangent of x is undefined. And let's think of it this way. If tangent of x is undefined, if the tangent graph is going up to infinity, well, what's 1 over infinity is going to be, as the number gets very high, as y gets very high, what's going to happen? Well, you're going to basically have the opposite situation here. Cotangent is going to be 0, because 1 over 0 you're going to approach this as long as the numbers here are positive. Everything between 0 and pi over 2 here is positive. Do the same thing here. I'm going to put a 0 over here on the cotangent graph where the tangent has an asymptote. Again, this has to approach a vertical asymptote. Is it going to approach this way, or is it going to approach this way? Well, again, 1 over tangent, and all the tangent numbers here are positive, right? So it's got to approach in a positive direction. And over here, this has got to approach in a negative direction, because all of these numbers here are negative. And I could even continue this here's pi, and 3 pi over 2. You notice the asymptotes are going to be every pi unit, so there we go. I can even continue this going this way. So you can see it kind of has, the tangent is going bottom left to top right, cotangent is going top left to bottom right. But that's the idea of cotangent. Okay, let's see if we have time for a couple of quick examples here. Secant 0.5x minus 1. Okay, first, real quick, let's take a look at the amplitude. The amplitude is still going to be 1. I'm not changing any amplitude here. This is not, there's no vertical stretching. We're doing two things here. The period is going to be 2 pi over 1/2, right? So that's going to be 4 pi. And we're going to have a vertical shift of -1. So we're going to take this and shift it down by 1 unit. Again, let's look at our base secant graph here. Secant graph, again, so we have asymptotes at pi over 2 and 3 pi over 2. Okay, so you see, normally the asymptotes, these asymptotes, this is going to be pi over 2 and pi as you can see in the secant graph. But of course, pi over 2 and 3 pi over 2 are going to be, but of course, we have a period of 4 pi. So everything's going to be stretched out. So this is going to be pi, that's going to be 2 pi, and 3 pi, and so on. I'll make negative pi out here. That's because the period is increased. Period's 4 pi. So 1, 2, 3, 4. The last thing to notice here is that it's being shifted down by 1. So instead of your graph starting here at 1 and going across, it's going to go down here to 0, and you're going to have the graph going up like this. And of course, instead of starting at -1, this thing's going to start at -2 and go down like that. That's one complete period of this secant graph. Okay, in the final example, cotangent of x minus pi over 4. Let's again refresh ourselves about the graph of a cotangent function. Again, normally we could draw a period from 0 to pi, going down right to left. Try to do this quickly. With an asymptote here and asymptote here. But again, we're going to the left by pi, oh no, to the right rather. We're going to the right by pi over 4. So instead of going from 0 to pi, let's kind of draw some marks here. The asymptotes, instead of being at 0 and pi, we're going to draw asymptotes at pi over 4 and 5 pi over 4. And of course we're going to have a 0 in the middle. And down right to left. And that's one period of this function. Again, we can extend this. We have asymptotes every pi units. So you can make another one at 1, 2, 3 pi over 4. Have the same thing over here.